So this is a program called manipulate underscore output.cpp that's in your Canvas page. So again, open it up in WordPad and then do a Control A, do a Control C, make that new project, console application. Let's give it a name, make sure you have no spaces in the project title. And then just go back and pull up your main or your project code. And then again, if you're using Xcode, make sure that you maintain whatever main you already have because it's using a slightly different console set. But if you're in CodeBlocks or if you're in Online GDB or Visual Studio, you can just remove the Hello World program that it starts out with and then paste your program in. So let's take a look at what this program is doing. So we're going to use what are called I/O manipulators, and then we're also going to use some input-output flags. So you'll see in the preprocessor directives we have # include IO stream. We've got to have that anytime we're doing output or input using cin or cout. But we're using a new one here, # include, and this is IO manip. So I for input, O for output, manip for manipulator. So this will let us use set precision and then also setw, which is the set width. So in this program, this is just kind of a demo of the features. We'll use this later in the course to start setting up some data tables. So I'm going to demonstrate with a float, a double, and an int. I'm intentionally putting some extra digits into the float rather than what it can actually hold. Floats can reliably hold about 6 digits. It's a little bit more complicated than that, but 6 is a good rule of thumb. A double can hold approximately 15 digits. Again, it's a little bit more complicated than that, but 15 is a good rule of thumb. So we've got 9 in this one, and then we've got 19 in this one. So we're going to go over the storage limit, and we'll see what that does with our program. We're going to print out a header like we're going to set up a table, and then we're going to print out a bunch of different ways. So let me go ahead and get the program going, and then we'll go over the output. At the same time, we're going over the program. So there's our data header. So the X float, Y double, A int, and I just put float, double, and int in there just as a reminder. But if you're doing a data table, you might have the units in parentheses in each of those cases. Then let's just print out the numbers with the simplest cout statement that we can do. So we've got cout. We're printing out the value for X, then Y, then A. But there's no spaces anywhere in there. There's no separators other than just the input-output separators. And so sure enough, with the output, we get everything just all stuck together, and it's really impossible to figure out where one number starts and one number stops. So let's go to the kind of the next level, and let's print out X, Y, and A, but let's print out a single space in between each one. So that would be our next line. The problem with creating a data table this way, though, is that if you use numbers that are larger or smaller, then if you go to, say, a double-digit number, it may shift this number over a little bit. It may occupy more or less space. And so then when you try to set up your data table, it'll look really uneven. So let's go to the next option, which would be that we're using tab spacings in between. So we're getting a little bit more sophisticated each time. With the tab, since it's a single tab character, we're going to use the single quote and then the backslash and then T for tab. There's a set of control characters that are listed in the appendix in your book, or you can find them online. But anytime you see a backslash inside of either a character or a string, it works in either one. Then the letter that follows the backslash is the control character. So in this case, T for tab. If we had an N there, then it would do a new line, so it would be a return spacing. So you can see that line here. It looks virtually the same as what we did with the single spaces, and that's just a coincidence of how the tab spacing worked out in this IDE. Now let's start using our input-output manipulator. So this next line, line 28, is not going to print anything out, but we're going to set the precision to 4. So we haven't set any other flags at this point, so when we do a set precision and we're just in that default mode, we're going to get 4 digits in our number, and that includes the digits before the decimal and the digits after the decimal, but the 4 doesn't include the decimal number. So now let's print out these same numbers again with the tab spacing, and now this line. So you can see the float prints out 1.235, so it rounds the 4 up to a 5, and you can see you've got 4 digits in that number. With the tab spacing, you can see you're getting a primitive table now formed. The tab spacing is not going to be perfect, but it's getting the start of a table. And then you've got 1.235 again for your double. And again, it only has 4 digits. And then look at what it did to the integer. It did absolutely nothing. So set precision is not going to affect the integer. Anytime you have an integer, the whole value is going to print out. So now let's start setting some format flags. So the format flags, and these are a little bit complicated, but they're summarized in page 73 in your book. So the format flags that we might want to use would be show point, which forces a decimal point, scientific, which will try to force scientific notation, and then right or left justify. And I'll show you some additional format flags in the next example program. So to use a format flag, we're going to start another cout statement, just like we did with set precision, and then we're going to send it fixed. So notice this is a little bit different though. With set precision, we do the std : cout, we do the usual operator for cout, the less than, and then we do std : set precision. Set precision works as a function or an object, so it takes a value. So you can see the open close parentheses and then the 4 inside the parentheses. Fixed really is just a flag, so it's either set or it's not set. So you just send it fixed. Notice there's no open close parentheses after fixed. That will trigger the fixed flag, and then when the fixed flag is set, then it'll print the numbers out in fixed notation. So there'll be a decimal point that's fixed. Now set precision is going to be doing something completely different. So notice we're not changing set precision between line 38 and 42, but when line 42 prints out, we get 4 digits after the decimal. So set precision is kind of tricky. Before you set that format flag fixed, set precision gives you the total number of digits before the decimal plus after the decimal. After you set fixed, then set precision is going to give you the number of points after the decimal only. So that's why this went from 1.235 to 1.234 and then 6, and that's rounding the 57 off to 6. So now let's go to sort of the next level in our table development, and let's set some column width spacings. So let's just do the whole shebang again, because this way you can go back and play around with this program and try commenting parts of it out. So even though we've already set fixed, I'm going to set fixed again. And then let's do a set precision 10, just so we can see, hey, what's really going on with that double with those digits? Did they really get preserved or not? So we'll get 10 digits then after the decimal with both float and with double. Again, it won't impact the integer value at all. And then we're going to do a cout, and we're going to use this command. So this setw is the set width, it's also a function or an object. So you open parentheses, and then you give it the column size that you want to print the number in. So if we looked at this number that printed out and we counted each of these spaces, we would see that this number printed out right justified in 16 spaces. If we looked at the next number here, we'd see that this next number printed out right justified in a 33 space width. And then the next number printed out in a 27 space width. Set W or set width only affects the very next variable that you send to it. It's not a flag. So if we remove this set W, we wouldn't continue to have a 16 column spacing. It would just push the Y value directly onto the back of the X. Keep in mind, most of the time with the table you'll want that right justification, but if you do want left justification, you can trigger that with that std : left to force left justification, and you could alternate back and forth if you ever needed to, just by sending the flag before you printed out that value. So when you get this program, try pulling it up, try commenting out some of the lines. What I mean by that is go up to line 17 and start a slash and an asterisk, and then come down to line 43 here and start an asterisk and a slash, so that all this part is now commented out, and then try and run it again so that you're able to see your table a little bit better. And then just play around with the values that you have here. Try and alter things, try and alter the spacing. Note that whatever you change to the spacing is also going to shift these two values over, and see what you end up with. Try going back and changing set precision to make that larger or smaller and see what you end up with. Try to use enough that you're going to the point where the float is past the number of digits that are stored correctly. You can see that, and with this one, the last correct digit really here is that 7, because the 8 should have rounded off to a 9. So we've got 1, 2, 3, 4, 5, 6, 7 values. We said at least 6, so we're in good shape. We don't really have enough values here, so try changing that to be bigger and see how that affects it. And then notice that none of the things other than set W is affecting the integer. So give it a shot. Hope you enjoy being able to now format your output. And we won't use it so much on program 2, but when we get into some of the later programs, we'll use these ideas quite frequently. Thanks for watching.